How Akshat? How are you doing?
I'm good, sir. How are you?
Very good, very good. So, what is going on in maths, and what do you want to do today?
So we got our midterms back, and I'm sitting at a 98% right now.
98%.
So
Wow,
yeah,
that's great.
yeah.
Yeah,
And we just started Unit 6 from the Nelson book, which is trigonometric functions. And we're on the Radians chapter right now, but I was hoping we can go ahead so I'd be more prepared for when they actually teach the other chapters.
sure, sure, sure. So that has been our strategy. We are slightly ahead of the class so that you get everything what has been taught there in the class, right? So let me share with you just whiteboard, and then from there we can move forward.
Yeah.
Correct. Now, to begin with, can you tell me what is the default measurement for an angle?
Degrees, sir.
What? So see, this is very important question, right? Default
Yeah.
angle measurement. So you'll be surprised to know it
It's
is
radians.
not degree, it is radians.
Yeah, I
And
was
that
thinking
is
that. Yeah.
radians. You understand? It is radians. Very important question. It is radians, not degree.
Yeah.
Now, since we start learning angles in terms of degrees, we get an impression as if degrees is the default unit. Actually, it is
Yeah.
radians, right? So that's very important to understand. See, and radians itself is a ratio, and it
Yeah.
is not really a unit. You get my point. It's just a ratio. You'll soon realize. And if it is a degree, let's say you have 60, you have to always write degree like this, right? Saying that this is a degree. On the other hand, if I have, let us say, 3 radians, I may write like this as 3 radians, or just the number 3 for the angle. It will also mean radians. Sometimes we write 3 and then R on the top, right? Just to make it more clear.
Yes, sir.
Otherwise, it is important to understand that radians is the default unit for measuring angles, right?
Yeah.
Also, if you're doing calculus, very important, if you're doing calculus, in that case, all angles are in radians.
Oh, okay. So no degrees, right, sir?
No. You will soon learn that the trigonometric function is not really valid. When you talk about uh, derivatives and integrals for the trigonometric functions, then in that case, the angle should be in radians. Otherwise, the limit, which is the base for our calculus, is not defined when the angle is in degrees. Okay, so that much of difference it is. So that's
Yeah.
our beginning for radians and degrees. So I hope you understand how important this topic is. Unfortunately, it is only taken at the end of the school, right? Grade
Yeah.
12, last semester, you learned that the angle should have been measured in radians, right?
Yes, sir. We don't even know that radians is standard until now.
Correct. And to give you an idea how standard it is, if we have a circle, let me just sketch a circle here, right? So if you have a circle like this, let us say, right? And with the center, let's say O, right? That's the center O, and the radius R. In that case, what is the circumference C?
2 pi r, right, sir?
Perfect. So the circumference is 2 pi r, correct? Now, the difficulty in case of circles is that how do we measure the circumference? It is very difficult to measure the circumference because it is a curved surface. Get the idea?
Yes. Yeah.
It is a curved surface. So let's go back a bit and understand how Egyptians figured it out, right? So what they saw is that and it's very obvious that, if I have many circles of different radii, let's say this is radius R1, for example, correct?
Yeah.
In that case, they found that the ratio of circumference, when you can measure this by putting a lot of points and then thread around it, and then that thread can measure, then you can straighten out the thread and then figure out how long it is, correct? For a
Yes, sir.
given radius, or you can say diameter, right? Diameter is twice radius, correct?
Yes, sir.
So what they found, or you can see, that the circumference is really proportional to you can say diameter, right? I'm using diameter, which is twice radius, right?
Yeah.
If diameter is more, then the circumference is going to be more obvious, correct?
Yeah.
So that means the circumference should be equal to some constant times the diameter, right? So where this is a constant. Is that clear?
Yes, sir.
And this constant, when they did a lot of measurements, it came to be around 3.14 something. And
Oh,
they
pi. Yeah.
named it as pi. Do you see that? They
Yes, sir.
named it as pi. So we have a formula. The circumference is pi times diameter, or we can say circumference is 2 pi r. Does it make sense to you?
Yes, sir.
So this circumference comes straight from pi, and pi is
Yeah.
an irrational number. We exactly do not know what is the value of pi. Pi is an irrational number, right? You know that part?
Yeah. Yes,
Pi
sir.
is irrational, right? And this irrational number is approximately, could be written as 22 by 7. Is it okay? Sometimes
Yes, sir.
we use this value, 22.7, or we normally use, let me say, a value which is 3.14. Is it okay? So these values could be used if you want 2 decimal place accuracy. Is that clear to you?
Yes, sir.
2 pi r, right? Now, you will also notice that if I go around the circle, right? So if I am only interested in that much of the length, it will be proportional to the angle, correct?
Yes, sir.
Theta. And if I go more, it will be like
A
more,
larger
correct?
angle.
So it will
Yeah.
increase, correct? If I go full length, then it is 2 pi r. Do you see that?
2 pi r. Yes.
Then it is 2 pi r. So 2 pi r is the circumference for full circle. Is it okay? Full circle.
Yes, sir.
So they give this 2 pi as the angle measurement for full circle. So 2 pi
In
is
radians, right, sir?
radians. It is all radians. It's a ratio.
Yeah.
So 2 pi is the angle of one full
Yeah.
circle. You see, which is equal to 360 degrees.
360.
That's the idea.
Yeah.
So see the connection. Now we call it 360 degrees. They call it 2 pi, where 2 pi is the radian measurement for full circle. You get the
Circle.
idea? Correct? So that is radian, right? And let's go back. I'll erase this part, and then we'll look into another relation, and which is again with the same circle. So I'm just giving you a few concepts. I know everything is there in the book. Let's say this is an angle theta, and this is r. Correct?
Yes, sir.
Now, how is this theta defined? Now, the thing is, this is that they call this as arc length. This is called arc length A.
Arc. Yeah.
Arc length A. Sometimes we write S for it.
Yeah.
Distance kind of, S displacement kind of, right? So A. So A is actually equal to R times theta. A
Oh,
is
so
equal to
yeah.
R times theta. You get the idea?
So theta is A over R, right, sir?
Yeah. So theta is equals to A over R. And if A is equal to R, then what? Then theta
is 1.
equals to R over R, which is 1, right? So
Yeah.
that is how 1 radian is defined.
Oh, okay.
So 1 radian is the angle which will give you an arc length equal to radius. Do you get the idea?
Oh, yes. Yeah.
So 1 radian is the angle which will give you arc length equal to radius.
1. Yeah.
1 theta. Is this correct? So that
Yes,
is
sir.
what 1 radian is. So you get an idea of what 1 radian is, correct? 1
Yes,
radian.
sir.
1 radian, you can also see the units. If I see what is theta equals to, so let's get back to our equation, which is theta equals to A over R, correct?
Yeah.
What is the unit of A? Let us say a unit of length, right?
Yeah.
And radius is also same length unit.
Same length. So units cancel, right, sir?
Do you
Yeah.
see? So basically, the unit for theta, which is radian,
Yeah.
is nothing, right? It's nothing.
Nothing. Yeah.
It's basically nothing. It's just a ratio.
Yeah.
You understand now?
Yes, sir.
But yes, we call it radian. Is it okay? So
Yes, sir.
it is a ratio of 2 lengths, which is arc length divided by the radius. Is this part clear to you?
Yes, sir. Absolutely clear.
Absolutely clear. So
Yeah.
if my angle theta is 2 pi, then what is arc length? Arc is r, A is r theta, right? So from here we
Yeah.
know A is r theta, right? A is r theta, and if theta equals to 2 pi, then A is
2 pi r.
2 pi r. Do you see that again? Circumference,
Yeah.
which
It
is
all
the
links up.
circumference,
Yeah.
which is the circumference, because we travel the whole circle. You get the idea? So
Yes,
that
sir.
is how the angles are being measured now. So this is the angle, right? Angle as defined is between two rays. So these are two rays, correct?
Yes, sir.
Meeting at the vertex. And that is the angle which we are always talking about, correct? And even today, the angles normally we write in letters Greek alphabets. So sometimes we use alpha, sometimes we
Yeah,
use
beta.
beta, sometimes we use gamma, sometimes we use theta, sometimes we use phi, and so on, right?
Yes, sir.
So this part of trigonometry actually is ruled by the Egyptians.
Yeah.
And we have to be very thankful to them for such a good, uh, discovery or invention, whatever you may call, which
Yeah.
they have created, the whole subject which they have created. And because of this, making a perfect circle, doing accurate measurements, you still see pyramids and some very beautiful structures erected by Egyptians.
Yes, sir, for sure. Yeah.
So that's the beauty of it. Okay, so that's one part. And now it leads, so you've understood what theta is, what is AR theta. So let me
Yes,
clear
sir.
all this. And what we learned just now is that A equals to R theta. That is one thing which we have learned. A is what? We're talking about a circle basically, right? So we'll restrict ourselves to circle. These are angle measurements in circle. And let us say, well, this is what we have. This is R. This is R, right? And in between, we have the angle subtended by the arc A. You see, we say angle subtended by the arc A is theta. That is how we have to use the language, right? So
Yeah.
angle theta is subtended
By arc A, right, sir?
by the arc. So if I'm not labeling anything, let me right now label this as AB, okay?
Yeah.
By the arc AB. Now, here I'll take a moment. As you can see, the angle could be this also. You see that? The angle could be
Yes,
that
sir.
also,
Yeah,
right?
yeah.
So we call this as a minor angle.
Oh, the
Minor
angle you
arc.
just drew, right, sir? That's minor
This is the
angle.
minor arc, right? So the other arc which I'm talking about is the major arc.
Oh, so sir, is it similar to the related acute angle, something like that?
Yeah, no, not really. Related acute angle you learn for measuring angles for triangles. So
Oh,
so this, let's say this the full circle, circumference, the rest of the arc. Let me make a point here. Let us say a point P, right? So we will write the major arc as APB.
APB.
So
Oh, okay.
that will mean a major arc. But if I use AB, we are looking into the minor arc. It's a shortcut. So if I write AB, you have to go, minor arc means AB. But if I introduce another point, we are talking about the major arc. It is very important to understand. Is that clear to you? Correct?
Yes, sir.
And obviously here, the relation is 2 pi minus theta, right? So this is 2 pi minus theta.
Yeah.
Because the total is 2 pi, correct? So that is one part. Now, you have understood this AR theta. You also understood that theta is 1 radian. RAD also we write sometimes. Theta is 1 radian
Yeah.
for A equals to R, right? When the arc length is same as this, correct?
Yes, sir.
When the length of the arc is same as the radius, correct? Is
Yeah.
that clear to you? So we have learned all this. Now let's talk about converting degrees to radians first, right? So
Yeah.
we know that 2 pi, let me write here, 2 pi is equals to 360 degrees, and clearly pi will be equals to 180 degrees.
180. Yeah.
180. Now this relation really helps us to convert degrees to radians, right? For example, if I have 60 degrees, then 60 degrees, how many radians? That is what we have to figure out.
Oh, okay.
So
Yeah.
how will I do it? We are converting degrees to radians. Degrees to radians. Is that clear to you? So
Yes,
we
sir.
want radians on the top and degree in the
And degree
denominator,
on the
right?
bottom. Yeah,
So
yeah.
degree cancel. Is that okay? So you can
Yes,
see
sir.
degree is this part, 180. So do you see
Yeah.
that? So I'm multiplying by something which is 1. I know pi over
Pi
180 is
over
1.
180. Yeah.
1, correct? I have to
Yes, sir.
multiply or divide by 1, basically. But I want to cancel degree. So I'll write 180 degrees here and pi here. So degree
Oh,
cancel.
so
Do you see
pi
that?
over 3. Yeah.
So you get easy. Sometimes students, I think they get confused. Should I multiply or should I divide this time?
Yeah.
So that is the kind of thing which you have to understand. And, it helps to make visual like degree to radian. What should you do? Right. So if I am going from degree to radian, let us say in that case, uh, if I go in this path, what should I multiply by? Right. So you're
Yeah.
seeing degree to radian means we have to multiply by pi and divide by 180, right?
180. Yes.
But on the other hand, if I have to go from radian to degree, in that case, we will what do? Let us say we have pi by 2 as the radian, okay? Pi by 2 is the radian. This is in radians, right? I want to convert that to degrees. That means radian cancel. So I have to put pi radians here, which is equal to 100 degrees, right? Oh, sorry, 180 degrees.
180, yeah.
And so radian cancel, pi cancel,
Pi cancel.
and we get 90 degrees. You get the idea. So
yes, sir.
In that reverse order, we have to multiply by degree because we want to keep degree on the top, right? And radians in the denominator. So that is how you could actually convert degrees to radians and radians to degrees. Is that clear to you?
Yes, sir. Clear.
Okay. Now, talking about 1 radian. So can you give me an idea? 1 radian is equals to how many degrees?
Sir, I think it's around 50, somewhere around there.
You are close, but not quite right. 60 is even closer. And let me give you an idea. The exact value you can calculate is slightly less than 60, and it will make sense. How? Let us try to understand how it makes sense that this is around 60. Well, we know that 1 radian is when this R is equal to this, right?
Yes, sir.
So I can straighten this out to make it an equilateral triangle.
Yeah.
You know, the arc is slightly bigger. Arc is bigger, right? This is greater than R, right? A is greater than R, right? We know that, right? So if I actually make this equal to R, what do I get? I get an equilateral triangle. Do you see that?
Yes, sir.
So if this is R, right? I mean, this is not that good a line. Anyway, if this is R, that is 60 degrees, correct?
Yeah.
So now, but this is actually smaller than R, right? This R is smaller than A, right? So R is smaller than A. So R is less than A. Therefore, the angle is less than 60 degrees, slightly.
So just a little less, yeah.
So you can use a calculator to find the exact value, okay? So we have 1 radian. So what will you do to convert? We have to keep degree on the top. So we'll multiply by 180 degrees and divide by pi. And you get what?
57.3, I think, right, sir?
Yeah. So okay. So you get 57.3. So approximately 57 degrees this is close to 60 degrees to be precise. You don't exactly remember, but if it is a multiple choice question, it is close to 60 degrees, and that helps. Is that clear to you?
Yes, sir, for sure. Yeah.
Okay. Now, next question for you is, how do you measure the angle in degrees? For example, let us say I make this angle, right? I make this angle, correct. Now, if I have to find what is the measurement of this angle, how will you find what is theta?
Sir, so I think my first approach would be to see if it's a right angle triangle, right? And then use primary trigonometric ratios.
Okay. So, well, my question is slightly different here. It is to tell you that you have a protractor, right?
Yeah.
To measure degrees, right?
Yes, sir.
Do you have any protractor to measure radians?
No, sir, you don't.
Why? Because
Because
Egyptians never used protractors, right?
yeah,
They worked without it, correct?
right.
Now, how do you work without measuring instrument in the radians? Tell me, the big question, right?
Yeah,
We are saying angle measurement in radians is the basic thing, and that's the default thing. And imagine everywhere we find protractors only in degrees, nothing in radians. They
yeah,
don't. I mean, they could have written right, calibrated. It
yeah,
is a
yeah.
simple factor. We have to only multiply by 180 divided by.
Divided by pi.
I mean,
Yeah,
multiply by pi, divide by radians to convert it to radians. But no, nobody has done it so far. Correct.
yeah,
I'm not saying it's a selling thing, but it could be. People should make it definitely, but they don't make it. The simple reason is that you'll be amazed how easy it is to work with radians. Let me just show you, and therefore it doesn't have so much a market, right? So
yeah.
okay, so for example, now you have already understood 0 degrees and 0 radians is kind of same thing, right? Because the
Yes,
angle,
sir.
right? So let's say this is my origin. And if I am on this line, which I'm calling as my initial line, so it is like same, right? Now, I'm talking about a angle is, this is my initial arm. Then if I have another arm, which is actually here, and I open it, right? So this is called a terminal arm.
Yeah,
And when I open, it gives me an angle theta. I could, if I rotate it in this particular direction, so it is counterclockwise direction, right? So that is always positive angle.
positive direction. Yeah,
In angle measurement, this is always positive. Now let's look into what are the values of angles, right? And we know this is like half of 2 pi, total is 0,
yeah.
or one
So
full
pi.
circle is 2 pi, correct? So
Yeah,
if I do half, I get pi, correct? If I
yeah.
do half of pi, I get pi
Pi
by
over 2.
2, which is
And
90 degrees.
yeah,
If I do half of this, I get pi by 4. Is that clear to you?
yes, sir.
Correct. I could divide this into 3 equal parts, right? So if I divide into 3 equal parts, let's say kind of this I made purposely slightly smaller. So it is like, this is like 3 equal parts means 1/3, correct?
Yeah,
1/3. 1/3 of pi by 2. 1/3 of pi by 2 means pi by 6, correct?
yeah.
So this is 1 pi by 6, correct? This is 2 pi by 6, which is pi by 3.
Pi by 3. Yeah.
Do you understand?
Yes,
And
sir.
I could extend this. You could see this also. I could divide
Yeah.
into 1/3. So I will have let's say okay. So this is a vertical plane for me to draw, so it's not so easy. Anyway, so we have 1 pi by 6, 2 pi by 6, 3, 4, 5, 6. So we got 3 parts, right? 3 pi by 6, correct?
Yeah.
4 pi by 6, 5 pi by 6,
Yeah.
6 pi by 6. Do you see that?
So pi. Yeah.
7 pi by 6, 8 pi by 6, 9 pi by 6, 10 pi by 6, 11 pi by 6, and 12 pi by 6. Do you see that? So I
Yes, sir.
have measured all the angles in pi by 6. Pi by 6 can be also reduced to pi by 3. In some cases, 10 over
Yeah.
3 could be written as 5 pi by 3. Do you see that? So
And yeah.
you see how we got all the angles? This is
Yes,
1
sir.
pi by 2, 2 pi by 2. So I could also divide into the half of each quadrant, correct? As you can see,
Yeah.
right? And I get 1 pi by 2 pi by 4, 3 pi by 4. Do you see that? 4 pi
Yes,
by
sir.
4, 5 pi by 4, 6 pi by 4, 7 pi by 4, and 8 pi by 4. Do you see that? That becomes 2
Yeah.
pi. So in this, quickly, we could just divide these angles, the quadrants, into different ratios and get all our angles. Do you see that?
Yeah.
So we
Yeah.
can fairly accurately actually draw our angles even without a protractor while working with. You get the idea.
Yes, sir.
So that is how you have to draw, keeping in mind that the positive angles are counterclockwise. Is that clear to you?
Yes, sir.
So this gives you a basic on what the radians are and how do we convert degrees to radians. Is that okay? I'm
Yes,
just
sir.
looking for a few more things which we could convert, right, and learn more about. Now, if I have to find the arc length, for example, let us say,
Yeah.
let me take some questions from my notes. It is that let us say a point is being rotated here, right?
Yeah.
Let us say the circle has a radius of 10 units. In that case, if this angle here is, let us say, pi by, let's say, let's make this as pi by, let's say pi by 3. If
Yeah.
this angle is pi by 3, can you tell me what is this length, arc
Yes,
length?
sir. So we know theta is A over R.
Yeah,
So our theta is pi over 3, and we have to find A, which is A, and then R, which is 10. So it'd be 10 times pi over 3, which would give you the arc length.
correct. In whatever units this is, if this is in centimeters, this will be in centimeters, right?
Yes, sir.
Now, if I have, let us say, let me just erase this clear order. Okay. If I give you the angle, which is in, let us say, let me write this angle, let me write here angle, right? So it is a
Okay, sir.
reflex angle. Let me say this angle is 200 degrees, let's say.
Oh, okay.
Now tell me what is this arc length A?
Okay, sir. So you do 360 minus 200 first, or should be 160, and then you find
We
the
want the
radian of,
major arc, major arc, major
oh,
arc.
major arc. Okay,
Yeah.
okay. So we're finding the theta as 200, right, sir?
Yeah.
For the
And
major arc?
arc length, let me take this arc length as, let us say again 10.
Okay. Yeah.
So how will you
So
find this angle? Yes, arc length A.
so we have to find A, right, sir? And our
Yes.
radius is 10,
Yeah,
and our theta is 200. So convert 200 degrees into radians, sir.
correct. So it will be 200 times, when you convert to radians, you have to multiply
Pi
by
over
pi
180.
and divide by 180, use
Yeah, yeah.
calculator and find your answer. Is that clear to you?
Yes, sir.
So that is how you could find arc lengths. But remember, to find arc lengths, it is better to use degrees angle, correct?
Yeah.
You could also use ratio. Actually, let me just tell you an alternative method. You could also use ratio. Ratio, how? But again, you will see that pi comes automatically. You know,
Yeah.
one full circle, circumference C, let me write C for circumference, will be 2 pi r, right?
2
2
pi
pi
r. Yeah.
into 10, correct? 2 pi r in this case,
Yeah.
right? But we want only the arc length. So A will be a ratio. It is not 360 degrees, but 200 degrees, right? So it will be
Yeah.
2 pi times 10 times 200 over 360 degrees, correct?
Yes, sir.
So
So now
it
you
is
can
that
cross multiply.
ratio. But you will
Yeah.
see, as the formula goes, that 2 pi cancels and you get 180, right?
180.
And what do you
Yes.
get? You get the same result. 10 times 200 pi by 180, pi by 180. Do you see that?
Yes, sir.
So you could use the ratio of degrees also to find this angle, arc length. Is that clear to you?
Yes,
How?
sir. Absolutely
If
clear.
you are given the value in radians, you could do it directly, correct? So
Yeah.
that is more or less your first particular chapter on radian
Yeah.
measurements, and I think you got good concept about it. Can you summarize this to end the class?
Yes, sir, for sure. So today we basically touched upon what radian is, right? And of course, I thought that degrees was the main measurement, but to me, it was striking that radians is obviously the main measurement, right? And it's really cool to see how you can relate ratios to 2 pi r to the value constant pi, and how the Egyptian story actually comes into play, and how we're using it like 1,000 years after. So I found it really cool.
Yeah, great. Okay, then all the best. We'll continue from here in the next class.
Yes, sir, for sure. Thank you so much.
Bye.